In this video, we're going to cover functional groups. A functional group is a specific arrangement of atoms that undergo certain chemical reactions. For example, an alkene is likely to react similarly to a different alkene, but differently from, say, an alkyne, a nitro compound, an amine, or an aromatic ring. Our first functional group here is the alkene. The alkene is basically just a carbon-carbon double bond. What we have here are different R groups, and that's just telling you that those can be different things. So, for example, this is one type of alkene. You could also have an alkene where one group is a carbon, or you could have an alkene where two groups are carbons, and so on. So these are all different examples of alkenes. And we would say that all of these structures that I drew have the alkene functional group. Now let's look at the alkyne. The alkyne is a carbon-carbon triple bond. And again, the R groups mean variable groups. They can be hydrogens or they can be carbons. So you could have this as an alkyne, or something like this, or something like this. Those are all examples of different types of alkynes. Interestingly, the alkyne is one of the very few examples where we draw a carbon and it's not part of a bend. So there's actually a carbon here and there. The reason we draw the alkyne linearly is because that's actually the shape it takes on. Next, let's look at the nitro compound. The nitro compound only has one possible R group, but you can mix that up and have it be different things. So it could be single bonds, or you could go ahead and throw a double bond in there. So this compound that I drew has both an alkene and a nitro group. The nitro group is also a notable functional group in that if you draw out the Lewis structure, it's one of the very few that has both a positive and a negative charge. Most of the functional groups that we're going to look at are going to be totally neutral. That brings us to the amine. The amine has three different R groups, and those R groups can be hydrogens or carbons. So this is one example of an amine. You could also have an amine with two carbon groups attached, or an amine with three different carbon groups attached. And this amine here has an alkene as well. That brings us to the aromatic ring, sometimes also known as an arene or a benzene. And you can put other different things on that aromatic ring. And you can see that this is the aromatic ring. We can also put other different types of groups on there. So you could put a nitro group, and this compound has both an aromatic ring and a nitro group. Let's take a look at our next set of functional groups. What's common to all of these functional groups is this C double bond O that I'm highlighting here. And for that reason, these are commonly referred to as carbonyl compounds. Carbonyl is another way of saying C double bond O. These functional groups are notable in that a lot of cases, the R group has to be a carbon and not an H. And I'll show you what I mean by that. First, let's take a look at the aldehyde. The aldehyde can have any sort of different group on that left side. We could throw in an aromatic ring if you want. So this compound has an aromatic ring and an aldehyde. You have to be careful, however, not to confuse the ketone with the aldehyde. The ketone has to have a carbon group on either side of the C double bond O. So this compound that I drew here is a ketone. The aldehyde very specifically has to have an H on one side of that C double bond O. And with the ketone, you can't replace one of these R's with an H, or you're going to end up with an aldehyde. Next, we have the carboxylic acid and the ester. The carboxylic acid very specifically has an OH next to a C double bond O, whereas the ester has to have a carbon group instead of an H on the other side of that O. So this is the ester here, and the other one I've drawn is the carboxylic acid. With the ester, you have to make sure that whatever the R is, it's carbon-based. If it's a hydrogen, you have a carboxylic acid. The amide is similar to the amine in that the groups that are attached to the nitrogen can be hydrogens or carbons. I'll draw some examples. So here's one type of amide. We could also mix it up and put an aromatic ring on there and have one group be a carbon chain. And then this amide here has an alkene and 2 carbon groups. So there are several different types of amides that you can draw because the R groups can be either carbons or hydrogens. Okay, next we have the alcohol. The alcohol can have any sort of carbon chain along with an OH group. Please note that the carboxylic acid does not contain an alcohol. Also note that the number of carbons between the carbonyl group, or the C double bond O group, and the OH is important. This compound that I've drawn here has an alcohol and a ketone. If we got rid of this carbon group here, then you'd have a carboxylic acid. Next up, we have the ether. The ether has to have carbons on either side of it. If it doesn't, and one of the R groups is an H, then you just have an alcohol. So here's an example of an ether, and those 2 groups can be the same, or they can be different. Both of those are different types of ethers, and the ether is not to be confused with the ester, which has a carbonyl group. So these 2 are ethers, and an ester would have that C double bond O. An ester is just an ester. You can't say it's a ketone. You can't say it's an ether. It's just an ester. Next up, we have our alkyl halides. The X can be fluorine, chlorine, bromine, or iodine. So I'll draw some examples. All of these are examples of alkyl halides. This particular one has an alkene as well as an alkyl halide. We could refer to this one specifically as an alkyl fluoride, this as an alkyl chloride, this is an alkyl bromide, and then the alkyl iodide. Last but not least, we have the nitrile. The nitrile has a triple bond from a carbon to a nitrogen. And it is not to be confused with the alkyne, which has a carbon-carbon triple bond. So this is the nitrile on the left and the alkyne over here on the right. This table from your book gives you some examples of not only the functional groups that we went over, but also some that we haven't. The ones that I expect you to commit to memory and really be fluent and conversational in are the ones that I had on that first slide. Just to recap, on this slide, we've gone over the alkene, the carbon-carbon double bond, the alkyne, the carbon-carbon triple bond, the aromatic ring. We've also gone over the ether, the nitrile, the ketone, and the aldehyde. We have not yet covered the thiol or the acetal. You will, however, see those later in this course. This is the rest of that table. Of course, we went over the alkyl halide, the alcohol, the amine, the carboxylic acid, the ester, and the amide. We have not yet gone over the phenol, the hemiacetal, or the epoxide. And even with these 2 tables, this is just a very small fraction of the number of functional groups that exist. If you want to do a search online for functional groups, you can find a whole lot more. The ones that we went over are just the most common ones and the ones that you'll see most frequently throughout this course.